Assalamualaikum. My group members and I are going to explain on the project of advanced mathematical methods entitled Deflection of Beams. So I'm going to talk on the introduction for this project. Basically, the background of the study is about deflection of a beam itself. So deflection is actually refers to structure under loading, while the term beam is a component that is designed to support transverse loads. So the loads that actually act perpendicular to the longitudinal axis of the beam. In this project, we apply Laplace transform to find the curvature of the beam. So Laplace transform basically a linear integral transformation which enables one to solve many ordinary and partial linear differential equations. Lastly is we basically use the knowledge in theory of deflection in beams to analyze four magnitudes of deflection resulting from a given load. Moving on for the objectives, there are three objectives. The first is to study on how Laplace transform can be used to solve simple 4-point initial value problems. The second is to know how Laplace can be used to find the curvature of beams under load. And the last one is to learn how Laplace transform can be applied in the field of studies.
So moving on to our mathematical model. So basically there are 5 types of beam, which are simply supported beam, cantilever beam, fixed beam, overhanging beam, and last but not least is continuous beam. While there are 3 types of load, which are point load, or also known as concentrated load, uniformly distributed load, and last but not least is uniformly varying load. So in our project, we are only focusing simply supported beam with uniformly distributed load. Can you imagine beam as a bridge that connects a gap? For example, pinning bridge that connects roadway and valley for giving access to people and moving vehicles to another place. So here is our model. So the deflection y-axis is a function of horizontal position and obeys the differential equation here. So basically in our project, we want to measure the deflection of this curve from the distance up here. Next is the variable of parameter involved in our project is y-axis as the deflection or the distance away from the straight line here, qx as the load that push the straight line downward, E as the elasticity of the material of the beam, I as the moment of inertia. So this is ground and this is the length. So this is the y-axis, which is the deflection of the curve. Thank you.
Hi, my name is Muhammad Nasrullah, and now we're gonna proceed with the manual solution. This is the equation of our project, which is the fourth derivative is equal to the qx over ei, which is the qx over ei is the constant. And then we took the Laplace transform on the both side, where on the left side we get the s to the power of 4 capital of y minus s to the power of 3 y 0 minus s square y prime 0 minus s y double prime 0 minus y triple prime 0. While for the right side is equal to the qx ei multiplied with 1 over s. 1 over s is coming from the Laplace of transformation of the 1 here, so it's become the 1 over s. And then we substitute all the initial condition here into the equation, and then we get this. We get s to the power of 4 capital of y is equal to the qx over ei times 1 over s. And then I solve for y, and perform the inverse of Laplace on the both side, and I get the y at is equal to the q over 24 ei multiplied with the t to the power of 4 equal based on the table of the Laplace transformation. Now we move to the computer aided solution. As you can see here, this is our computer aided solution. Basically it is same thing. I just give the order to the program to perform the Laplace transformation, and finally we get the same answer with the manual solution. Now we move to the graph. This is our graph. This is the deflection of beam, while here is the load. As you can see here, as the load is increasing, the deflection will increase because the stress that develop inside the beam. That's all from me. Thank you.
Okay, finally, in the end of this video, we can see that the application of Laplace transform to the differential equation 1 is really useful in order to find the deflection of the beam as function of horizontal position along the beam. We choose overlay software to find the general solution of the equation and plot the graph of load against deflection of beam. Based on the graph, we notice that the graph shows an exponent line where the deflection start to slowly increase at the load increase until the load is at 0.10 kilogram, where it starts to increase rapidly. When the load exceeds the deflection limit, where it reaches certain value, there is no more increment in the graph. Lastly, we are able to write the academic report mathematically and systematically by using overlay and method. Thank you.